All right, Riza, why don't you get us going?
Great. Happy Kwaai Day, everybody. Gosh, the 26th meeting. Thanks so much. 26 means half of 52, means we're halfway through the year. Gosh, who would have believed 6 months ago we kicked off this movement with a single video call to action. The video's looking a bit tired now on the website, but hey, a new one's coming. Thank you so much. We got a lot to discuss today. I'm not going to take up too much time in the intro. We've got scale, we've got the NASA briefing to discuss, and lots of other things. Back to you, Matt.
Sure. So just some real quick announcements here to get us going. We had a great meeting with the scale team this week. Special shout out as well to Karsten Wade, who is also going to be speaking at scale on open source. Karsten is stepping up and volunteering his community organizing and community architecture skills to help us make sure we have a great event at the summit. He's also based down in LA, for you LA folks, Balaji as well. Get into the channel, get connected to the planning. If you would like to submit for a talk, we would love your idea. Please, to do so, fill out the Kwaai survey. That's my trick. You gotta go fill out the rest of that Kwaai survey to submit for a scale talk or to submit for a summit talk. But please, that's the other announcement that I would have. The survey is out there in Google Forms. I'll be sending a reminder at the beginning of next week. We're trying to collect responses by the 31st. And those responses include your feedback on things like what is the open source license that Kwaai should select for Pi. Very big questions that we need to answer. The board of directors will be considering all of the feedback from the survey, all of the ideas, all of the thoughts as they're voting to make that selection in early February. Once that selection is made, we can truly kind of embrace this, open source development spirit. Riza, anything to add from your perspective? Oh, actually, I had one other thing here. Tentative agenda is in planning. This is kind of how we're looking at the second Kwaai Summit, kicking off at noon, ending at about 5. Really broken down in a similar way to how we did the first one. There'll be a lot of opportunity to present what Kwaai is, our vision for personal AI, and what we're building. We'll leave a lot of time for questions, both from the audience and attendance. Because we're co-locating with Scale, we definitely expect to gather some attendees and some interested parties. We are the only AI-focused track that's going on Thursday. So anybody at Scale on Thursday is going to be interested in dropping in. We want to give a lot of time for people to ask us questions, as the advisors and Kwaai members will be in attendance. We need we're looking for volunteers for some of these keynotes. We're looking for volunteer panelists for the Q&A. And we also are embracing our typical style of member voices. And because I see some new names on today's call, let me just give a brief shout out to that. So member voices come at the end. This is where we'd love for you to introduce yourself to the Kwaai community here. We'd love to get just our voices from the community. I'm not going to call on everybody like I did last time, but we're certainly hoping to meet some new potential volunteers as part of our attendance alongside Scale. Riza, anything to add?
Yeah, some important things. Last year in our first summit, we titled it the Personal AI Summit. I think we need to do that if we want to garner more attendance. People that are going to come in on that Thursday are going to want to know where to go. So I think that'll be a great opportunity. Additionally, Scale have offered us a 50% discount for registration. Registration is normally $80. You're going to have to register, and there'll be a discount code if we release that. The other important thing is we have a booth. So we've got a booth for the entire duration of the conference. So we're going to look for volunteers for booth participation, if we're going to have demos at the booth, but also being on staff. So staffing up the booth is going to be important. And what are you going to be doing there? You're going to be engaging with the public who are coming, and you're going to be pitching Kwaai, and you're going to be evangelizing. So this is going to be an important part of what we do. Thursday is our summit, but the conference goes on right through. Does it go through Saturday and Sunday? I'm not sure. Anyway, that's will be available on the Scale 21X website. So let's do those two things: the title and the booth. On the keynote, the sort of main keynote, I've got two possible big hitters, but I'd like some more, or I'd like some more options. Neither of them are confirmed. So if there are any big names that you think would be a possible keynote for Kwaai, and someone that whose name we can publicize in advance to get more attendance, that would be great. We will be streaming the conference live. Last time we did that as well. We streamed through LinkedIn. We also streamed through Zoom, and we'll probably do that again. And I think we've got a fairly good AV support. We've got Joey and his crew coming on with cameras and mics and so on. In addition to all of the speakers being mic'd up, there will be opportunities. He'd like to actually interview each of the Kwaai participants, and that'll be material that we can repurpose later on. This is an important milestone in the movement and publicizing the movement and evangelizing. The purpose of it would be, since the main audience is a developer community, you know, Scale is the biggest Linux developer conference. So what we need to do is leverage that. We need to hone our outreach to that developer community and make sure that, you know, we get a good influx of new membership. Great, that's it. Back to you, Matt.
Yeah, very well said. Great reminders, Riza. Real, just quick point of clarification. Registration for Scale is not required to attend the Kwaai Summit, but highly encouraged. We would love for you to attend. Scale was kind enough to sponsor us. It is not required if you're not able to stay through the week, but it was just really inspiring actually to hear from the organizing crew and the way they think about openness and knowledge sharing. So fantastic event. If you're coming out to the summit, definitely stay for Scale. Awesome. So
sorry, quick question on that. Did Scale, did we figure out the registration fee for Scale? And would that for people coming with Kwaai, would there be somehow a waiver? You know, because people might come with Kwaai and then be like, oh, you know, they don't want to pay that fee. And then
yeah, there'll be a coupon code for registration. We're waiting on that from the Scale team. So to get your discount code, yeah, go ahead, Carson. Yeah, please jump in.
Yeah, definitely. There's a discount code, and in fact, I think they mentioned that they often get discounts as a source. But what I wanted to just to tap on around on that was that to say that Scale. So I've been to Scale a number of times over the years since the Scale 6, I think, was the first one that I went to, and for the Los Angeles broader area, it's a really well attended public event for people. From the general public, but what that means though is when somebody comes up, when like a 12-year-old comes up and talks to you, that 12-year-old may be a smarter Python programmer than most of the people you know, and your high school classes who just like need a 30-second explanation of what's going on and so forth. And part of this is because the cost to attend like the expo hall is I don't think it's free, but it might be $25 or something. And then the highest, the conference cost, like the most you can pay cash with no discount codes, I think it's $80 for all of the days. So it's really accessible. And the key thing is too, is that Pasadena is located where everybody can get to it with about an hour of driving. So it's a great Saturday event. So Saturday becomes the day where a lot of people come in, the broad general public is there, the expo hall is gonna be really busy, the whole area will be filled up. It's gonna be, probably a beautiful day, like all that kind of dynamic. And so that's always been a specialty in terms of what made Scale from the very beginning happen, was coming out of a Linux install fest community, basically, and then expanding out into this. So just kind of that's part of keeping in mind. I'd be happy to answer any other questions about it. I'll bring up some other stuff in Slack so we can answer more questions about what it's like. So
yeah, I didn't realize the registration was so low, because usually science conferences, the registration is like $500. So I was like, that's manageable. It's $25, $80. That's awesome. Okay, that's good.
Yeah, no, and that means that, like, you're talking to somebody from JPL who's there for they get the people from Disney and so forth. So yeah, it's a pretty great event for that. So great, thanks.
Yeah, Kai, real quick, and then we got to move on.
Yeah, maybe I'm completely off, because this day I'm completely overwhelmed. But March 14 is the day that Scale start as well, right? So we kind of in competition with that. Can that be like the day before?
Thursday's a workshop day. There's some longer workshops, 2 hour, 3 hour workshops. So yes, we'll be competing with the big hands-on workshops. But we're the only AI focused track, so we'll certainly attract anybody that's kind of wandering in on that first day.
Okay.
Cool. Let's keep going here. We got a lot more today. Balaji is going to give the lightning talk today. I would love for a volunteer for lightning talks. If you would like to do a lightning talk, please hit me up for next week or a following week. Today, Balaji is going to help us really understand LLMs. And so he's been a guiding force on a lot of our Pi architecture calls. He's demystified a lot of the language for me, helped me understand where I've been conflating a lot of my understanding. So without further ado, I want to pass it over to a true leader here at Kwaai, Balaji, to help us decode LLMs.
Thanks, Matt. Thanks everyone for allowing me to present here. This is a wonderful opportunity for consolidating a lot of my thoughts, and pardon any errors, omissions. I'm merely trying to fine-tune myself to this concept, so there could be hallucinations. Fair warning. Okay. So let's start with the topic here: large language models. And I couldn't resist myself adding that first line. I tried very hard not to go philosophical, but I think this is all intertwined. So I'll start with that to set a framework as to where we are reaching for and where we are. So as we go through the material, we know we are just beginning. So I sum it up in the sense that we are experiencing reality every day through our own perception, and a combination of perception and filling up the rest with our imagination. So everybody has their own version of reality in a sense, and that's the premise for all of these models. How does that relate? We'll walk through some of this. So what changed? A key change that happened, again, neural networks have been there for years. Gosh, I remember studying as an elective 25 years ago. But I think now when they figured out how to model attention. So that's pretty much summed up in that attention is all you need paper in 2017. And modeling attention is a breakthrough that started creating some waves in this industry. Transfer learning. So when a system learns a wide variety of concepts, is that transferable? So advances in this, again, transfer learning, fine-tuning, some of these are synonymous in this industry, but there's also advancements in learning there that helped propagate these systems. Larger the better. So why large language model? So in these experiments, over time, people figured that the two factors, the number of parameters or weights in the network, or it's a function of attention heads, that creates a lot of these weights. When you scale that and when you provide a lot of text, they find even today that the system is still continuing to learn and it's not topping out. So essentially that means you throw additional data at it, it is still able to figure more relationships between the information given, and it sums up as intelligence is probably free. As we continue to throw more and more data, it's going to discover more relations. That's why people are after larger the better. And they're after all these GPUs, throw more data at it to scale this. One final thought on this slide is that, so how far does this go, right? Again, if you pay attention to everything, do you pay attention to anything at all? That's, again, I'm landing that in a philosophical note, right? So there has to, again, as humans, we don't pay attention to everything, right? We pay attention to certain things and we specialize, we focus. We'll go to the next slide. Okay, let's walk through compression and prediction. These are intimately related, one and the same. A lot of these models take information, compress it in one form, and how does that help prediction? Again, prediction, if you, again, I've been in this audio, video streaming and compression industry for a while. After a while, you realize that you get better at prediction, you also get better at compression, higher the compression. So these two concepts are related. Large language models basically do one thing, is especially with the generative pre-trained GPTs, the single job it started was to predict the next word. That's it. You start off somewhere and it goes predicts the next word. You feed the thing back, you predict the next word, keep iterating, get better and better. And that's the main functionality. I think if one thing you want to carry away from this is that these systems are good at predicting the next word. That's it. Lossy and lossless compression. So the system we have built with these LLMs is a lossy compression. So if you take a look at the large language model like Llama 70B, the statistics was that they took probably 10 terabytes of web data and compressed it to 140 gigabytes. It's probably a compression ratio of 70. By given compression standards, we do like 5 or 10 or 20 in the imaging prior. So that tells you that, yes, it is taking information and converting to some other form. It's a lossy form, and it's getting compensated by filling it up with its own imagination. And that's where you get all the genius and the dreams and hallucinations, because now it's trying to fill the gaps with the missing information from its knowledge base. So what does that look like? I just wanted to paint a picture. What's a neural network? What does it even look like? I mean, it's just a bunch of connected nodes, and these nodes and the links carry weights, and those are all what they call parameters or weights. And in this example, the system is trying to predict cat sat on a what, right? Based on its accumulated knowledge, it comes up with 97% probability Matt is the next one. And then you feed that to the front of the thing, and then you say, hey, what is the next word? And what is the next word? And keep going. That's basically what the system's trained to do. Okay, sorry, having trouble with my mouse here. Okay, there you go, the keyboard. All right, so what's the general process here? So you feed the training text to a network, and the model generates the next word in the sentence or wherever you started it off. And the model prediction is compared to the actual text in the training data, see whether there is difference. If there's difference, which is called the error, you go adjust your model weights and optimize the whole thing for very low loss. And this is a system, again, you can hear people saying it's like a black box. You're adjusting the whole system as a whole, not as a part. So thereby this problem of people don't know what it does internally to come up with the output, but they're able to adjust the predicted output as a whole. And evaluate the previously unseen data and feed something that it has not seen and see whether it can generalize the output to what it has learned. And this has been general framework for any neural network. You just this process follows, except here we are trying to predict the next word. Let's look at some basic terminology. I'm going to speed through this. When you look at Hugging Face or anything, when you look at a model name, what is this, right? Nomenclature. So the first thing is the model name, which is base model name. We'll come to what that is. It's called Llama. Base model version, which is Llama 2. And then the parameters are how many model weights, how much information is contained in that 7 billion parameters are contained. So it's 7B. And then you have fine tuning or alignment notation. It's fine tuned for chat. And then fine tuning versions. Then comes the HF. In this case, it's Hugging Face who did the fine tune, or it's 0.1 where somebody did it, right? So, and then what is the actual data format? The GGUF is more unified format for portability purposes, or GGMO, which is specific to certain systems. So this is how the nomenclature so far has evolved. So when you see a name like that, you can take it apart, say who did that, or what is this, and more terminology, sorry. But this is a little bit more into day-to-day. Like when you hear prompt, what's a prompt? Prompt is nothing but a string of text. There's nothing more to it. People are complicating this whole concept of prompt and say it's engineering. Yes, it is sort of Googling, right? If you are a good Googler, you can definitely do prompt engineering. Prompt meta tags. So the prompt meta tags is something that when we work with open language models, we have to be aware of. The closed ones do not even expose. And that's probably one of the secret sauces in terms of how closed model do. So I put a screenshot on top right how these tags look like. It's just like a wrapper around your text. And that's how they train the base model. And when you feed the information in any other form, even an extra space, the system derails. So that's why people are like, oh, if I feed it this way and in this particular format, I get the best result. So I call it engineering. But it's not, primarily because when the version changes or the model changes, all your engineering work is you have to redo it. So it's not necessarily, maybe you're just engineering for that particular search. Token. Okay, I think I'm at a time limit. Is that continue or should I? 10 minutes.
We are running short on time, but this is super interesting, Balaji. If you've got a lot more, then we can keep going, or we can put a pin in it. But
yeah, I'll skip the terminology. I think this is reference material. I'm just trying to explain. Let's go to the next slide. I just wanted to cover a couple of things, maybe 2 more minutes. All of this material. Okay, so how to train your assistant. The basic idea here is stage 1, pre-training. It's been pretty much handed out to us by the big companies, by open sourcing it. They have spent a lot of time and money doing it. And it's consider this as a knowledge base that we can take it and try to focus on certain things. This is where a lot of questions arise. What do you turn it on? This knowledge base, because of the transferability of the knowledge, is a big concern. So that's a different topic altogether. So fine tuning is you take the base model and then you try to make it pay attention to what you want it to do. So I kind of think it of a knowledge worker, right? You take a knowledge base and you say, this specific knowledge worker works on this particular focus area. And these are the steps involved in trying to get the fine tuning done. And the stage 3, which is still an evolving stage, is like RLHF, they call it. How can I use humans? Like show the variations, let the human pick the right answer, and then feed it back into the system to refine it. Retrieval augmented generation is the last one I wanted to cover. This topic has been around. Essentially, this technique involves taking material you have and finding similarity scores in a semantic space. Essentially, in terms of word, it can be similarity of a word or context or sentence or documents. It can be similarity at any level. Most common ones are doing like BERT models do context semantic space, and it gives you embeddings. And now you can present your question and it will tell you how related chunks are, where are they, and you can retrieve them and present it to these large language model to convert it into like a what do you call a refined output, like somebody is talking back to you type of answer. That's essentially it in terms of RAG. Think fast and think slow. We are in a stage where we are imitating with the AI. Maybe the next stage is to think slow and try to reason. Future possibilities, smaller language models. Self-improvement is a major topic. It's done with some games. You have seen games like chess or Go or anything. It's a simple reward system, win or lose. So models are able to improve continuously based on that reward system. But real complex problems don't have simple reward systems. So this is something that's still evolving. Multimodal is already here. Maybe multimodal. You can chain models to achieve some results. And I wonder system 1 plus system 2, is that AGI? References. Thank you so much. I couldn't cover a little bit more, but I think I try to do the best I can. 10 minutes.
Fantastic. That was super helpful. Awesome summary. I really liked how you broke some of that down. We will definitely share out this deck. And, Balaji was kind enough to share his wisdom. Balaji, really appreciate you putting this together. And again, really appreciate your leadership. We're going to save questions here. We are running a little short on time, so I'm going to keep pushing through. I'm going to steal the share back.
Yeah, I think something is stopping my mouse from moving around now. All right. Got it.
Okay, so some work group updates and just real quick. I put this little graphic together. Our work groups are expanding, they're changing in their kind of structure. It's been fascinating. So just a quick summary, the tools group is really split up into 2 core engineering efforts. We have the back-end systems. Balaji is leading a lot of that. The model design, what we need to do to make Pi work. We also have kind of the front end experience. How are people going to communicate and use their Pi? And this is really where we're focused, especially right now in the deliverables for scale. Our demonstration of the communications assistant, Pi acting in a way so as to help you manage your email communications. The fundamentals group, Rees is doing research on fluidic neural networks. Kai is doing work on machine reasoning and policy. We had a great kickoff meeting. We'll share a little bit more about, but focused on 3 core goals here. The one I wanted to highlight was really the evolution of the AI and life sciences group, which is almost evolving as a super group here at Kwaai. And Diego's been leading this. Thank you, Diego. Diego started testing model accuracy, has some very interesting results on the ability for GPT 3.5 Turbo or GPT-4 to answer drug interaction questions. This feeds into a lot of what we're thinking about on the policy side for how do we help consumers understand how accurate their models are. And then as we evolve this, what's a Pi ability, an application that we can use to help its principal users? So like a personal drug interaction screener based on the latest medical data. Pinar gave some fantastic feedback as a medical doctor of what she would like to see in an assistant in life sciences. So really love to see this come together. Please get involved in these channels. Please get involved in these meetings, and I won't take any more time. I want to pass it over first. Actually, sorry, that was not my agenda. Pass it over first to the AI and life sciences group. Diego, would you maybe spend 5 minutes, just give us a quick summary on your research and the next steps?
Hi, everyone. So we started this project on the life sciences subgroup, in which we wanted to assess first how accurate these systems are, like LLM systems, at giving you back some healthcare related information, because this is how we imagine people are going to use it, right? So you are going to ask your LLM, does this drug that I am taking that the doctor just prescribed to me is going to cause me this adverse effect, or what is the indication of this, or am I going to be allergic to this drug and just the doctor didn't know that I had this other problem, right? And this sort of question, so even before trying to use personal healthcare data together with the LLM, I think a fundamental question was, can they tell us what is generally known about, for instance, drugs or medicine, right? And to answer this question, we started a project on analyzing drug side effect data. I think the reason was also because I've been working on this type of data sets and problem for many years during the PhD, designing machine learning models for predicting side effects of medications. And I know very well the data set that we could use, the ones that are curated. And so we had this gold standard that we could use to ask, for instance, ChatGPT. So we asked the two different versions in which we design binary queries basically to say to ask the system, can you tell me whether this drug causes this adverse effect, and just give me a binary answer. So the reason for this is because in this way you can frame a binary classification problem, which is already well known, and we know how to measure it in terms of machine learning frameworks. And then you can use any binary classification metric basically to measure the prediction accuracy in a way. And this is what we did, right? So we started doing some I started doing some experiments just for general drug side effects by randomly sampling from all the drug side effect data that we have. But then we realized that there were some issues with the knowledge of the system. So what happened was that, or the hypothesis based on the initial results was that ChatGPT knows more information or have more information about certain drugs than others, because we found some oscillation, some big variation in the prediction performance obtained by this system. And then to actually understand this better, I did another evaluation for single drugs. So I took specific drugs, and then I asked the system specifically for those drugs. And this is where we basically confirm that these systems are very sensitive to the information they have for specific drugs. So for some medication, they can give you up to 90% accuracy, but for other drugs, they give you like 20-30% accuracy. And this is probably because they were trained with much less data about the other drugs. And I think the next things we want to do, the next research moving forward will be, for instance, how can we use other information to add contextual context or more information about specific drug in order to improve the prediction performance for those drugs. That would be one of the things we want to do going forward. I don't remember the other goals. Then we also had the goals of trying to do personalized medicine, but for that we need more patient-specific data. And I think Afshin can help me here with that.
Yeah. Oh, you want me to jump in?
Yeah.
Yeah,
If you
yeah.
remember another goal we wanted to
So I
do.
remember that. So the idea is like, you have a positive control, and how do you test this? So, you're talking about looking at the New England Journal of Medicine, right? Papers and finding
Exactly.
case studies. So the idea would be then, for people who don't know, there's a lot of case studies that are published online from New England Journal of Medicine, thousands of them all the time. So in these, they'll have like a patient who had a certain disease in there. They'll say they took those drugs, and then this is the outcome. So it has everything you need to train. If you go through the papers, it has everything you have to actually show what happens to the drugs, and it has the outcome. So if your model actually did it accurately based on the actual results from these papers. So that's the idea, right, Diego? That's what you wanted to cover there. Yeah.
Exactly.
Fantastic, Diego. Thank you so much. Really appreciate the efforts there and the focus. Sorry, did I interrupt you there? Do you have more?
No. I think that's it. That's it enough, probably.
No, really good. And the other thing it just really kind of gave us all an aha moment about is the binary classification that how can we objectively measure the accuracy of these models? If we're talking about drafting an email response, it can certainly be hard. Kai, we're going to save the big quick one here.
Just to say that personalized medicine and precision medicine are two different things. It's very important to know that pharma, they are looking for precision medicine because they still want to have some people to sell their drugs. Personalized medicine, it's really only you. And pharma, they don't care about that. And having the two approach, you have to use different kind of technology. Just want to appreciate that.
Fascinating. Thank you, Kai. Really great work, Diego. Join that group. That's meeting Tuesdays at 10 a.m. Get in the Slack channel. Riza, why don't you update us on NASA?
Great, thanks so much. And Diego, great presentation, great body of work. And I love the fact that you have created this methodology for figuring out the error rate by which the large language models respond. So that's important. Okay, so I'm going to present. If you can allow me to share, I'd like to share a deck, and then I'll go 17 slides, but I'm going to go through it in 7 minutes. Okay, so soon I will have that permission. There we nearly got it. Okay, bang, share now. Window, share, and then that goes. Great. So thank you so much for Afshin for introducing us to NASA. And so this was the NASA AI Machine Learning Working Group, and Stilvan requested that we provide NASA a briefing about what is Kwaai. And so a lot of this stuff is stuff you've seen already. I went through what is the crisis in AI. We talked about the elephant in the room, that monopoly power is the dominant trend in AI, and there's an increased monopolization. That seems a bit esoteric. So how did we translate that into practical terms? It was a recap of the arguments that we made at DataCon LA, that AI is a leap forward, but that there's problems ahead. And so we talked about, we described the problem, and then we described that an altruistic intervention is needed, and Kwaai is such an altruistic intervention. It's a grassroots movement taking practical steps to counteract the oligopoly, developing personal AI, fundamental AI research, and drafting policy, all in the service of democratizing AI. So it's a call to action to NASA to join the movement, and we have to explore what joining the movement means for an organization like NASA that is typically very slow moving, but it's made up of lots of rocket scientists, lots of big thinkers, and so getting them individually to come and participate could also be a good outcome. So we went through what is Kwaai. I'm not going to repeat that here, but we all know the pitch when we're talking to others, when we're trying to evangelize the movement, when we're trying to get people to come and participate. We talk about how we are practically converting this mission of democratizing AI into 3 practical work groups, rather than being passive about it and just moaning and writing passive blog posts. We're doing something concrete. We are creating open source software. We are researching into fundamental AI, and we're drafting policy. And so we touched a bit on what is personal AI. I gave them a walk through this sort of system diagram. Thank you so much, Matt, for creating this. I think we're going to evolve this diagram a lot more, but it talks about the need for personal AI. We democratize AI by enabling us all to own our own personal AI. Kwaai develops a personal AI operating system that allows you to secure your own personal data and interface it with third-party systems. Kwaai develops example apps like the Pi Communications Assistant that we'll be demoing at scale, and following close on its heels, a Pi Healthcare Assistant. So how does this democratize AI? Well, frankly, it's more efficient for us to own our own AI, own your own digital twin, rather than vendors and service providers trying to glean your likes, preferences, and beliefs through cookies, pixels, quizzes, and other tracking technology. You know, there's $1 trillion industry that is so super inefficient trying to figure out what my shopping needs are. Well, why don't I just tell you? If I own my own AI, my AI could tell you what my shopping needs are, and then you won't pester me with travel offers for the trip to South Africa that I took already. You should know that. I know that. Why am I still being bombarded with offers? So it's more efficient for us to own our own AI. That's a simple rule. Okay, it's not about democracy. It's just more efficient. The center cannot hold. Things fall apart. There's not enough electrical power to feed into a data center to be able to support the AI needs of a large population. So just at a physical efficiency point of view, there's a strong argument for everyone to own their own AI. Okay, it's fairer, and it promotes distributed ownership and self-sovereignty, but it's also safer, because when your personal information is owned by third-party systems and siloed in various service operators' data centers, that represents a honeypot for hackers, and it's so much safer for everyone to own their own AI, and then you don't have these centralized honeypots for attack. So we talked more about that. We talked about our AI policy track, that it's
Riza, why don't we combine the AI policy work group kind of update on how we're organizing? Just what are those three areas? Spend a little bit of time here.
Right. Okay. So the employment contract terms, these three goals of our policy AI track. One is to draft employment contract terms that anticipate AI. It's really about how would your tools of the trade, which are becoming smarter and smarter, we anticipate that you'll have your own personal AI that you'll take to your next job. How do those smarts that you own, how do they interface with the corporate systems where you're going to be employed? And then that AI will become smarter on the job. What of that do you retain? And what of that does the employer retain after you've gone? The current contract in employment is that you'll have my skills for the term of my employment, but once I've left, you don't retain that in perpetuity with no residual rights. So that's the sort of argument that's been playing out in Hollywood in the actors and writers strike. It's coming for every single job. So we need to be right. That's right in the crosshairs of what we're doing in this bullet point here of the contract terms anticipating AI. Similarly, there's a plethora of open source license frameworks for sharing code, for distributing code, but there isn't the same for data. What if I want to share a repository of data, but I want to retain the PII? I want to keep that private. I only want to share the embeddings. I only want to share it in some anonymized semantic space. There doesn't exist such a framework, such a licensing framework. I think the industry needs it, and I think that's where Kwaai can participate. And I think this idea resonated with a number of people on this call and in our group. So the other stuff we talked about, and we call it nutrition facts because we're in the US. When we described this to our colleagues in the UK, they said, "What are you talking about, nutrition facts?" It's a metaphor. It's a metaphor for a certification framework for AI models to give them more transparency so that vendors can say, here's the performance, here's the size, here's the implicit bias in the model, but here's also the scope of the data and the provenance of the data upon which it was trained. And maybe Kwaai becomes a certification organization. I know this is not novel. There are organizations doing this already, and maybe we can figure out how we participate in this area. So those are the three main goals of the AI policy track. We kicked off meetings. Fortunately, it's on Sunday, but we can talk more about the timing of that and how to get more participation in the policy track. Okay, Here's the area I'm going to dwell on for a few minutes. Because I was talking to NASA, I thought they'd be interested in AI fundamentals. The goal is to make models that learn and think concurrently, converge faster, and train on much less data. The general research for AI fundamentals is on technology that will allow models to be smarter, faster, and greener. Models have an awful carbon footprint. Balaji spoke about, how old neural networks are. They are really old. And I talked about 3 possible areas of work. I dwelt a bit on my own journey through AI. I'm not going to bore you with that, so let's click through this. The perceptron, developed in 1943, and we're still using the same math. I think we can do better. The deep neural network is in fact a network of these perceptrons. At each node, the computation that happens there is the sum. It's like a sum product in Excel. It's the multiplication of the weights, which are on these lines, by the value of each of the previous nodes, and then summing that up, and you end up with a new value that goes in this hidden layer. And then it progresses on. And we don't know why it works. It seems to work. It seems to converge to a value. And as we increase the number of layers, then a bizarre thing happens. If we increase it too far, it starts to diverge. We don't know why. And it just works. And we do that. And we do that. And that's what's called deep learning, deep neural networks. It's a forward pass, and then when we get to the end, we check it with some ground truth, and we say, oops, that didn't work. Now we go backwards, and we find, how can we adjust each of these values, each of the weights, in order to come up with a closer fit? And we do that iteratively, and that's the state of play of deep neural networks at the moment. This network can't learn and think concurrently like we do. The training process happens in a massive compute instance because it's so compute intensive. And once it's finished and you've settled on these weights over here, which are the thicknesses of these lines, and you get an output that matches close to the ground truth, then you say, okay, that's it, our model is trained. And those weights are in an array. That array could be.
Riza, sorry, I don't mean to interrupt the deep parts here. We are running short on time. Get to some member voices and the engineering update.
I'm going to rush through this quickly. Okay, so can't learn and think concurrently. The other area of work is on the geometric perceptron. We'll come on to that separately. I'm currently working in the area of fluidic neural network. It exhibits causality. It is the math of this I've worked out. I've started simulations on it, and Colin is helping me on this. A causal neural network, one that exhibits cause and effect, one where it's more deterministic. And we've simulated that. I've simulated it, and Colin Miller is helping me on this. If people are interested in what this could be and what happens in the neural network, it's potentially a dramatic simplification of existing deep neural networks. In a causal neural network, there are only 2 connections from one node to the adjacent layer. So you only connect to the nodes that are in immediate contact. So you don't have the number of weights growing in an n squared term or exponentially. The number of weights grow linearly. So it could be a dramatic simplification for the class of networks where you're trying to solve causal problems. So what does this mean? Here's the final slide. fluidic networks could represent a causal network. It's based on locality. There's a speed of determinism. There's a speed of causality, and it could explain the limit of determinism, and it could help us build better reasoning AI. More to come on this. And then there was just the call to action to join the movement after that. Okay, I'm going to stop there. Thanks very much. End the show. Stop.
Fascinating. Thank you, Riza. Appreciate it. Cyan, why don't you give us a quick, minute update, and then what we'll do after that is have a quick opportunity for some member voices. If you would please like to introduce yourself. There's a couple new names, and my tradition is you might get called on if you don't, volunteer your hand there. So please do introduce yourself. We want to prioritize folks that haven't had a chance to introduce themselves before. Let me get to your slide there, Cyan. Sorry about that. All right.
All right, thank you. Good morning. So this is going to be really short. Oh, I think that's not the correct one.
Nope.
Sorry,
we didn't get it. We didn't get it loaded up correct.
Yeah.
Why don't you just give us a quick verbal? Sorry about that.
Sure. So basically, this week we will be focusing on fine-tuning the LLM model. We were revising some versions of Llama, the 7 billion one and the Tiny one, and we're running some tests regarding the prompting to these models. We're also checking the minimum hardware requirements for it to run. So basically, we're establishing everything so we can work on that next week, and we're going to be finishing up the query prompting process for the graph responses next week. And this week we were able to finish some bugs that we have in the email categorization, and that was pretty much it. That's a short summary.
Awesome. Thank you, Cyan. Really appreciate that. Thank you, Arcus Nexus team, for your sustained involvement here. Really great to see the progress. So for member voices, would love to have the new folks that are here raise their virtual hand before I call on you. If you've just joined the Kwaai meeting today, thank you, Norman. If you've just joined today, I'd love to hear an introduction.
Hey, everyone. My name is Norman Terrell. I'm a global product management and data science leader. I help align product and data science initiatives with business goals, build a product roadmap, and then working through the product development, marketing, and launch cycle. I'm located in San Diego and had the opportunity to hear Riza speak at a recent AI and digital biology conference at the end of the year, and was intrigued by the mission of Kwaai and wanted to get involved and look to contribute in any way I can.
Awesome. Well, thank you for jumping on our weekly meeting, Norman, and great to meet you.
Nice to meet everyone.
Another name I'm not entirely sure is brand new, but Ty Green. Do you want to say a few words? I haven't seen you in a while, maybe, or you new? I'm not sure.
Yeah, good morning. Ty Green here. Product guy from Silicon Valley, now down in LA, working on a new piece of software that we're keeping under the lid. And some of my colleagues from the Bay invited me to Kwaai, and so I know I don't know, so I'm here to listen and learn. And I thank you again for allowing me to be here.
Awesome. Well, welcome, Ty. We're happy you are.
Good to see you again, Ty.
Sorry, Riza?
Yeah. Good to hear your voice again. I'm sure Toby sent you along. Say hi to him.
Will do. Yeah, it's been a couple years, Riza. Last time we connected was South by, like, years ago.
Yeah, years ago.
Awesome. The small world of AI. Folks, those were the new attendees. Great to meet you both. If anyone has any thoughts, comments, questions, topics to think about, we're heading into the end of the Kwaai Day call, so this is an opportunity to get the gears turning over the weekend. Would anybody like to share something? All right. Well, in that case, we got a shy group today. Riza, why don't you take us out?
Excellent. Thanks so much, everybody. A lovely Kwaai Day. We are working furiously to try and get to make sure that our second summit is going to be successful at scale. This is the immediate focus for us. The broader focus is on funding. A deck is in preparation, but a teaser video I placed on the message channel. It's worth looking at. That'll probably go out Monday. And I'm going to blast that out pretty widely. We are halfway through a year. We started in July, so it's an opportunity for us to reflect on what we've achieved. We've achieved a lot. We've got 3 working groups off the ground. We're making a lot of progress. We're heading to our second summit. We have through a lot of discussion, solidified our mission and translated that into practical work going forward. We've got an organization, probably 150 strong. At least people have signed up. And we'll grow this to about 1,000 by the end of 2024. It's a developer community. You're all volunteers. You're giving up your own time, and you're doing that because you feel that this is a worthy cause. This is an essential cause. This is a movement we must participate in, because the alternative is quite frightening and dystopian. So when I think about where I want to invest my time and energy, I'm always thinking about the Kwaai mission and what are the practical things I can do to move that mission forward. And I hope you're all thinking that as well. And if you have any friends and colleagues that you want to bring along, hey, get them to join up. Tell them to come and sit in on a Kwaai day on Fridays, and let's grow the movement. Thanks very much. We're running up into the next session, which is the hackathon session. So I don't want to stamp on that, but I really
one final ninja announcement. We're doing a live webinar next week. Sorry, I didn't put a slide together. Live webinar from Carsten Wade. He's going to be talking about what open means and what open source licensing is in the age of AI, carrying on from his lightning talk last week. We would love to use Kwaai as a platform to help you all share your knowledge. We saw, Balaji, do that today. Please, if you'd like to get a lightning talk, or if you'd like to think about maybe doing a live cast webinar publicly, contact me, let me know. Happy Kwaai Day, all.
Happy Kwaai Day.
Happy Kwaai Day. Have a great weekend.
Bye-bye. Thank you.
Bye-bye.
Thank you, Mike.
Bye.